This video is from chapter 5 in the textbook, and it's on functions. This is the first part of the video on functions, where we're going to be using functions that are already built into C++. In the second part of the video, we'll be actually creating our own functions. And in the third part of the video, we'll be talking about how to use function prototypes to make our code a little cleaner. Okay, so we'll define a function here, but we're going to define it further. And let's go ahead and do it in code here. So a function is a reusable block of code. Okay, so we're going to use it when we have some code. When we get to writing our own functions, it'll be things that we don't want to have to do over and over again. We'll be able to do it in a function. Think of programs we've had where we want to display a menu. Well, rather than doing that in your main code, you can have a function to do that for you. Okay, or the is prime calculations we've been doing could be encapsulated into a function. Okay. We're going to talk more about how functions are actually implemented once we get to the second video and into the third video. Okay. But for today we're just going to use functions that are already there. Okay. So when we can use a predefined function, it's just going to save us some time. There's a lot we don't have to do. Okay. So the main ones that we're going to use, there's a math library in C++ called CMath, and there's also a string library, which is going to have the math library has a bunch of functions that do mathematics we haven't been able to do before, and the string library has a lot of things for string manipulations. Okay. So one thing to keep in mind, we don't have access to all of the libraries when we start. The reason we do that, this include statement that we're using, it's called a preprocessor directive. It's going to load in the entire IO stream library before we even get started. Okay, so we don't want to do that for all possible C++ functions because there are so many of them, it would make our programs gigantic. So the C++ standard library has been divided into sections so we can just pull in what we need. Okay. So up here in the top, you can see I'm up here. If I want to use any of the math functions, I have to include the CMath. Okay. It has the octothorpe like the other one does. It includes all the same. The octothorpe is how we know it's a preprocessor directive. You may call the octothorpe a hash symbol or a pound sign or a tic-tac-toe board, whatever. But the name of this is CMath, and because it's a built-in library, we're going to enclose it in angle brackets. We're going to eventually write our own libraries we can pull in, but for now, we're gonna keep to the standard. Okay. So the CMath library provides a bunch of mathematical functionality. Okay. A little anecdote here. When I was programming for an insurance company, they asked me to do a project that had to be done in C++. At the time, I had never used C++ in my entire life, and I had 2 weeks to get it done. I was used to doing a program language called BASIC. So I didn't know or I couldn't figure out how to get the math library to load. So these were the days before the internet, so I couldn't just Google it. So I had to take the time to create my own square root function, which was painful. So you don't have to do that now that we know this. Okay. So the CMath library has a bunch of functions, and those functions typically take, so functions in general are going to take a set number of parameters, the things we send, and then it may or may not have something that it returns to us. Okay. So the first example we'll do is that square root function. Okay. And that is sqrt. Okay. It's going to take some x where x is a number. Okay. So let's start with an example here. We can just say sqrt of 25. Okay. We can compile this and run it and see what it does. Ran okay. Running it, nothing. Okay. It did nothing because I didn't tell it to do anything. Okay. So this function, the parameter here is 25. It's going to send it to the sqrt function that is in the CMath. We don't have to tell it that. It knows that it's there. Okay. It's then going to return 5, which is the correct answer, but we have to do something with that 5. Okay. So we need to either see out the 5, which we can do. That's one way. Okay. So now if we run this, compile it and run it, you'll see that it gives us the 5, which is correct. Okay. Or And we can try, let's do something that doesn't do an even number. So let's say we do 27. Okay. Should be close to 5, should be a little over. Compile it, gonna run it. Yeah. And that returns as a double. Okay. So the default typically is going to be we're going to return that as a double. Okay. So that's the other thing we could do here. We could say something here double S is equal to SQRT 27. Okay. And then we could print out that variable S. Okay. If we do that, okay, it's going to give us that answer. Okay. Now note, if I wanted to instead make that an integer, see what it does. It's going to work for us. No errors there. It does work. Okay. So it's going to give us, it's going to move that to the nearest integer. Okay. It's going to lop off what it is. Okay. So an issue with that could be there could be a loss of generality in that if the number gets over 5.5, then it's not going to correctly, it doesn't round it, it just chops it off. Okay. So it's always better to keep those as doubles. Okay. So those are the two options you have with the output, okay, of a function. Okay. Something else we've wanted to do for a while that we've not been able to, okay, and that's to raise something to a power. So that's what the POW function for the power. There are two parts here. There's the base and there's the exponent. Okay. So for example, if I wanted to, um, let's say we've got a circle. Okay. So the radius is equal to 5. Then we can say, I need that as an int. And I could say that the area, double area, is equal to 3.14159 times the power function. What am I raising? I'm raising the radius to the 2 power. Okay. I do have to spell or type double correctly. And then I should be able to see out that area. Okay. There we have the area. Okay. And we can validate that to make sure that it works. But it should be good. Okay. And again, that's going to be a double. Okay. In fact, with the pi should be a built-in constant in the math library, but I sometimes forget. Can I just do it this way? If not, I'm gonna have to look it up. See if this works. Nope, doesn't like that. Okay, so it wants, um, it may have to be math.py. I'm going to stop the video just briefly and check that out. Okay, I looked it up. I'm thinking more Python on that. So there is a constant that's defined, but it's not in the standard library. It is in the math library. It is in most implementations, but not all. And that's m underscore pi. So let's try this, see if it works. I believe it does work on our system, and it does. So we can run it, and we get the same answer. Okay. So the advantages to using the m underscore pi is that it's going to give the full precision of pi in the type, the double that it's using, which is more than we would typically want to type in ourselves. Okay, it's also a lot easier to use. Okay, so that's another of the functions that we have. We have the power, again, some number to some exponent. Okay, we also have an absolute value function, which comes in handy sometimes. Remember that an absolute value function is going to return the positive of whatever you send it. Okay, so if we have int x is equal to -24, then I can see out the absolute value of x. And that is going to give us the 24. Okay. So other things that we can do here, there's a ceiling and a floor function. So for example, I could here for the square root of 27, which is 5 point something, I could say the floor of that. Okay. If I run that, that's the first number in there. Okay. It's going to give us a 5. Okay. So that's going to take the lower number. So it's going to move to the left, the lower whole integer. Okay. And alternately, if I wanted to do the ceiling, it's going to round it up basically. So this rounds down, floor rounds down to a whole number, and ceiling is going to round up. Okay, it moves it up to a 6. Okay. So when there are times that you want to round up or round down directly, then those are the functions you want to use. Okay. There's also a whole host of trigonometric functions. Okay. So if you want to do sine or cosine or tangent or any of those things. So let's say I wanted to print out the sine of pi. I could here do a sine of m underscore pi. Okay. When we run it, we see it gives us this crazy number at the end. Okay. For whatever reason. Um, let's try. Isn't I thought pi was something we did a lot with sine. Let's try 9. It may be in degrees, and that may be what's messing it up. So let's see if this looks any more reasonable. Yeah, that's a better number. That's the sine of um, 90 degrees here. Okay. So you have sine, you have cosine, cos, tangent, tan. Okay, and those are the basic functions that we use. Okay. There are other functions out there in the math library. If you look through them, you can do, if you go to like C++.com, spelled out CPLUS.com, or maybe Geeks for Geeks, you're likely to find a table of all of the mathematical functions that you have. Okay. There are also string functions. Now, we haven't talked a lot about strings. We're going to have an entire chapter about strings later, but let's just do some basics here. Okay. So to get these, we have to include the string library. Okay, once we've done that, just get rid of this stuff for now. And remember, strings act like they're variable types, but they're not really. Okay. They're more of a data structure, which we'll talk more about later. So once we have a string, I think the one that we're going to use most would be the length. Okay. So we can say something like int L is equal to, let's see, name dot length. Is that how it works? Or is it length? We'll see. I always get confused on the syntax of that. I think that's what it is. It's name dot length. I think it is. Okay. And then we can see out name contains L characters. See if I've got that one correct. Yes, Bob contains 3 characters. Okay. So that's the big ones from the string function for now. There's a lot more with strings that we'll talk about more when we get to that. Okay. So some of the things we have to make sure we're doing in our code, we kind of talked about along the way. You have to make sure that when you call a function, so again, if we're going to call the POW function, we have to know that it takes that base and the exponent. Okay. If you send it just one, if I would say something like double X is equal to POW 4. Okay. I go to run that. It's going to give me an error. Okay. It's going to say it couldn't find anything that you were looking for. Okay. So it's going to find it here. Okay. So no matching function call. So we have the POW function. That's okay. But it takes an X and a Y. Okay. And it expects 2 arguments here. It tells us one provided. So that's a problem. Okay. In fact, it's actually going to point us. I saw it somewhere. Yeah, one version takes some longs and one takes floats. There's also one that takes doubles. Okay. So that's the issue with that one. We have to give it two, basically. Okay. So, and again, you want to make sure that the results of a function, these functions typically are going to send something back to you. The math function certainly will, as do most of the string functions. So you have to either print it out or save it as a variable. Okay, so to make sure that you have um, the right variable name or the right kind of variable is important. Okay. Um, the square root function, one thing that we'd say that it only printed when we did 25, it printed 5, but it actually is returning 5.0. It just doesn't do that. Okay. So just to recap what we've talked about in this video, we looked at the math functions and the string functions and built-in functions in general. We've already used some IO stream functions we haven't talked about in that cout and cin are both functions that we can use. Okay. And endl is basically a constant that's defined as a new line character. Okay. So they're useful. The built-in functions especially useful because we don't have to do them. Okay. We don't have to worry about the values of pi anymore. We can just go ahead and get as precise a value of pi as our system will allow, which is a good thing. Okay, so that's all good news. We also can do a power now without having to do number times number, which can get bulky. We have a square root now. We have absolute value. And there are other functions in the math library if you find that you need them. Okay. So it does really make our lives easier to do that. Okay. So that is video one. The next video, we're going to talk about how to create your own functions. Okay. That'll be a little more complex, but it shouldn't be too bad. And it's super, super useful.